Let's look now at our theorem about inscribed angles. You may have recognized, as you were looking at the different conjectures about the angles in a circle, that if I measure an inscribed angle, then I'm going to get the same thing. Well, I'm going to get half of the arc that inscribed angle intercepts. So let me show you that. We're going to construct that arc on the circle. We're going to measure that arc angle. And you see that the inscribed angle is 1/2 of the arc angle. And remember that the arc angle, by definition, is just the measure of the central angle that intercepts that arc. So the arc angle of GI is going to be the same thing. Is going to be the same thing as the measure of GAI. Right now we're going to focus on that inscribed angle. And we're going to show that if I have an inscribed angle in a circle, then I can prove that the inscribed angle is half the measure of the arc. Okay, now this is sort of an interesting proof because I'm not sure we've done one quite like this before. We are actually going to be proving 3 different possible cases of an inscribed angle. You'll see how this is going to be a good thing for us. The first case will be when A is on one of the sides of the angle. So the center of the circle is on one of the sides of the angle. So I'm going to move this up and I'm kind of going to cheat and just make it look like it goes right through there. There we go. We don't need these measurements anymore because measurements don't help us prove things. So we're going to start with the first case because we know a little bit more about this situation because of the radii. So let's see, we have GHI and HI goes through the center of the circle. So let's see, what can we say? We want to show that this angle here is half of this arc angle. Well, if I were to draw in this line segment here, then what we notice, which is always a good thing to recognize when you're looking at circles, is that we have 3 radii. So all those radii must be congruent. Okay, well what does that mean? Well, that gives us an isosceles triangle over there, and by the isosceles theorem, we would know that this angle must be congruent to this angle. How does that help us? Well, remember, we want to show that this angle is half of this arc. But we really don't know anything about how to prove something using an arc, but we know a lot about how to prove something using polygons and triangles and angles. So why don't, instead of trying to prove that angle H over here is 1/2 of arc GI, why don't we try to prove, so we're going to think, why do we know, let me get this out of the way a little bit. Why do we know that the measure of angle H must be half of the measure of angle GAI? Because if I can just show that the measure of angle H is half of the measure of GAI, then I've done what I set out to do because GAI is the same measure as the arc angle GI. Okay, so what does this angle right here have to do with everything? Well, what kind of angle is this? It's an exterior angle. So this angle right here is an exterior angle of this triangle HAG. Well, what do we know about exterior angles? Well, we know that the exterior angle is going to be greater than either remote interior angles. And even more importantly, we know that the exterior angle is equal to the sum of the remote interior angles. So that's the exterior angle sum theorem. It tells us that the measure of angle GAI is equal to the measure of angle H plus measure of angle G. Well, we know by the isosceles theorem and the definition of congruence that the measure of angle H is the same thing as the measure of angle G. So I can replace the measure of angle G with the measure of angle H because they're congruent. And now I can add the right side of the equation together, use a little addition. Measure of H plus measure of H is going to be 2 times the measure of H. And if I divide both sides by 2, then I get the measure of angle H is equal to 1/2 the measure of GAI. By definition, the measure of angle GAI is equal to the measure of arc GI. And so then I can just do a last little substitution. And I know that 1/2. I replace GAI with the measure of GI. And that must equal the measure of angle H. So we've just shown that in the first case where my inscribed angle side goes through the center of the circle, the inscribed angle has to be half of the arc, using just the exterior angle sum theorem and the fact that I have congruent radii, which gives me an isosceles triangle. And from there, it's just a little algebra. But that's just one case, right? Not all of our inscribed angles are going to have one side that goes right through the center. So let's consider a second case. Oh, different color there. Okay, case 2. In this case, let's get rid of all this stuff because we don't need that. In this case, A is in the interior of angle GHI. Okay, so there's another option. I can have A be in the middle of this angle, and then my last option is going to be for A to be on the outside of the angle, right? So I could have A be out here, and that's one option. I can have A be in the interior, and that's another option. And then last, I could have A on my line segment, which is my last option. So I've already done that first case. Now I'm going to look at the second one. And because we've already done the first one, the second one ends up getting pretty easy. A is in the interior of GHI. Okay, well, let's see. Let's add a ray through A. Well, now what do we know? Well, now this angle up here, there's a J. This angle right here, because now I have, is an inscribed angle with one side going through A. And we already know that if I have an inscribed angle with one side going through the center of the circle, that the angle is going to be 1/2 of the arc. So I know that this little angle here, oops, is the same as 1/2 the measure of GJ. That's the measure of that angle right there. And we know that because that's the first case where I know that my ray goes through the center of the circle. Well, I can do the same thing with this inscribed angle down here. It has one side going through the center of the circle. So I know that this little piece is 1/2 of the measure of JI. All right. Now what are we trying to do? We're still trying to show that the measure of GHI is 1/2 of the measure of GI. But what we know right now is going to really help us with that, right? Because what is the measure of angle GHI? Well, by the angle addition postulate, the measure of GHI is the same thing as the measure of GHJ plus the measure of JHI. So the measure of angle GHI, if I do a little substitution, and obviously this isn't really a formal proof, but I'm kind of just going through the explanation, is 1/2 the measure of GH. I don't know if that's happening to you each time, but sorry about all that zooming in and zooming out if it is. GJ plus 1/2 the measure of JI. Now I can factor out that 1/2, so now I know the measure of angle GH. Actually, I'll just do this up here. I can factor out that 1/2 and pull that out and put this in parentheses. Take out that 1/2, right? So we just factored out the 1/2 times all of this. Well, if you note, the measure of GJ plus the measure of JI is just the measure of GI. So this is sort of arc angle addition, right? So it's really just saying that if I add two arcs that are right next to each other, I get the full arc. So this is the same thing as GI, and we're done. That was pretty easy, right? We have one case to go, and the last case is going to be where A is not in the interior of the circle, and A is not in the interior of the angle. So let's see here. So now we're going to look at an inscribed angle that looks like this for our third case. A is not in the interior of angle GHI, and A is not collinear with H and I. Well, we're going to do the same thing. We're going to use what we've already proven. So we're going to draw a ray through A and do essentially the same kind of thing. So now what do we know? Remember, we're trying to show that GHI is 1/2 of GI, just like we've been trying to show each time. And now what do I know for sure? Well, I know a couple things about these angles because I have an angle right here that has a side that goes through the center of the circle. So I already know this angle is 1/2 of IJ. 1/2 measure of IJ. So we're going to see this is pretty similar to what we did last time, right? Okay, so that's the measure of that angle. Now, what about this angle? Well, this is what we're trying to prove. We don't know this angle is 1/2 of GI yet because we haven't proven this case. However, we do know something about this big angle, right? This big angle has one ray going through the center, so this big angle is going to be 1/2 of GJ. And now we'll have to remember that that's this whole angle right here. So now what? Well, I know by angle addition that the measure of GHI plus the measure of IHJ will equal the measure of GHJ. And if I do a little algebra to rearrange that, what I notice is that this whole angle right here, the measure of angle GHJ, minus this little piece right here, the measure of angle IHJ, is equal to the measure of angle GHI. Okay, well, what do I know about the measure of GHJ? I know it's 1/2 of the measure of GJ. And what do I know about IHJ? IHJ is 1/2 the measure of IJ. I can factor out the 1/2 like I did before. And what is GJ minus IJ? Well, GJ is this whole thing minus IJ, which is right here, is GI. So again, we end up with exactly what we want, that the inscribed angle, no matter where the inscribed angle is 1/2 of the arc it intercepts.